Hi everyone. In today's video, we're going to learn some more about spreadsheet modeling. We all know that Excel is a widely used tool across multiple industries in the business world. So we're going to learn more about the different inbuilt packages that are there in Excel and the functions that could be helpful to us as business managers. I'm going to cover some practice examples. Each sheet that I have here on my screen refers to one practice example that I'm going to cover with you guys. But if you want more information about these tools and functions that we're going to cover in this video, you can also refer to chapter 10 of the book, which covers these in a lot more detail. We all know that there are plenty of other specialized software packages also available, but those packages are usually a lot more expensive. So we need to learn how to use Excel because every company has access to Excel, so you wouldn't need to pay extra to use these tools for your day-to-day data analysis. Let's start off with an example over here that I have for a company called Nowlin Plastics. With the help of this example, I'm going to demonstrate how we can use some of the common functions in Excel and how we can use the inbuilt data analysis package called GoalSeek in order to run our analysis for us. Now, some of you might have these analysis package that comes with Excel already installed in your computers, but if you don't have them installed, then you can check, or if you don't know whether you have them installed or not, what you can do is click on data on your top ribbon over here, and let me adjust my screen a little bit. And if you find the additional analysis tool pack here in the top right hand side of the screen, then it's already been installed. But if you don't see it here, just like on my screen over here, I don't see any options here. What I'm going to do is I'm going to install them manually. For that, I need to go to File and scroll all the way down on the left hand side to Options. This opens up this window over here, and here I'm going to click on Add-ins. And once this opens up, I'm just going to click on Go. And here, the two main add-ins that we're going to be using are the Analysis Toolpack and the Solver add-in. So I'm going to check both of these and press OK. It's going to take a few seconds to load, and as you can see now, I have both the data analysis and the solver add-ins installed in my Excel over here that we're going to use later on. We're not going to use solver for the purpose of this video, but later on when we cover optimization models, that's when we're going to use the solver. So let's come back to our example over here. Nowlin Plastics has to make a decision, and this is an example of a make or buy decision. They can decide to produce their own products in-house by investing in a factory, or they could outsource it to a third-party contract manufacturer. Now, obviously, this decision is dependent upon the cost analysis. If it's cheaper to produce the quantity that they require in-house, then obviously the decision would be to produce it in-house. And if it's cheaper to outsource, then it makes sense to outsource it, keeping all other factors aside and not just focusing on the dollar cost factor right now. So the input parameters that have already been given to us are the cost of both producing it in-house and outsourcing it. If they decide to produce it in-house, they have to invest in a factory, which costs them around $234,000, which is categorized as a fixed cost, and every unit of product that they produce is going to cost them $2. So the variable cost per unit is $2 per unit. Now, the outsourcing cost, on the other hand, is 3.5, which is higher than the variable cost of producing it in-house, but it makes sense because they don't have to invest all this money in stuff like equipment, machinery, factory workers, all of that. So we want to analyze what is the quantity of goods at which Nalden Plastics is going to be indifferent between producing it in-house and outsourcing it. That quantity, we're going to call that the break-even quantity, because below that break-even quantity, it would be cheaper to outsource it to a third party, and above that quantity, it would be cheaper to produce it in-house. But right now, with the current information that we have, we don't know what that quantity is going to be. So what I've created here is a simple table, and I've listed some of the potential quantities that they could be producing, and what the savings are going to be if they outsource this instead of producing it in-house. That's what we're going to fill in these blue cells over here. So let's do a simple example first. If I'm to produce, let's say, 100 units of product, then the total cost to produce these 100 units in-house would be the fixed cost plus the variable cost multiplied by the quantity of product that I'm producing. So in total, I would be spending 234,000 almost, plus 200. And if I decide to outsource this quantity, then my total cost to outsource would be the quantity multiplied by the outsourcing cost. Now you see, at a low quantity like this, a low quantity of 100 product, it's obviously much cheaper to outsource this because you're not going to invest in building up a factory and running that factory. Instead, you just give it out to a third-party contract manufacturer who's going to end up producing it to you, for you in a much lower cost. So the same way, if this amount is to be a lot higher, let's say 200,000. In that case, you'll see that automatically the cost to outsource jumps up and the cost to produce it in-house is lower. So you end up saving if you build this in-house, which is the phenomena of economies of scale. If you produce more of a product, the fixed cost gets divided over that higher quantity of goods and you end up saving. So let's try to see where this break-even cost lies within this range of values that I have added to my table here. In order to find out what my savings due to outsourcing are going to be for each of these quantities listed here, I need to build a formula here. So the savings would be the total cost to produce minus the total cost to outsource. So first I will add the formula for total cost to produce, which is the fixed cost plus the variable cost. Now notice what I did here. I added the total cost to produce in this one bracket over here, and within that I have the fixed cost plus the variable cost. The variable cost is the variable cost per unit, which is in cell B5, multiplied by the quantity of goods that we're producing. In this case, that's in cell D5. Because my input parameters are going to remain the same throughout my formula, I want to keep those cell references constant. So since my fixed cost in cell B4 remains constant, I'm going to add $signs here in front of both B4 and B5. What these $signs do is, what you'll notice is that once I've completed this formula, I can simply drag it down to calculate the savings for each of the quantities given in the cell in column D. Now, to do that, I want to keep these references constant as I drag my formula down. And that's what the dollar signs are going to do. The dollar signs keep the cell references constant when you copy and paste the formula elsewhere. I'm not going to put dollar signs in front of D5 because I want that to change based on the quantity that I have listed over here in column D. I only want my parameters to remain constant, which is the fixed cost and the variable cost. Now, this takes care of my total cost to produce, similar to the formula I had in B13. From this, I'm going to subtract the cost of outsourcing, which is the unit cost of outsourcing multiplied with the quantity that we outsource. It's going to be the same as the quantity we would have produced otherwise. And similarly, I'm going to add dollar signs in front of the outsourcing cost per unit because that remains constant throughout the example. Now, a simple Excel shortcut to add these dollar signs is to press F4. So if I keep my cursor in between the cell references that I want to keep constant and I press F4, the dollar signs automatically appear. And I keep pressing it, it's going to change, and you can remove it the same way as well. Now I'll press enter here, and obviously at the quantity 0, it's better to outsource because you're essentially setting up a factory but not using it. On the other hand, if I'm producing 25,000 units of this product, then it might be cheaper to outsource and I might get a savings value for outsourcing as well. So to get the savings due to outsourcing similarly that we had for this quantity, we're simply going to click on this cell and go to the bottom right hand side of the cell until this black plus sign appears, and I double click on it. It's going to copy the formula all the way down for me throughout the table. Now what you'll see is it has automatically calculated the savings due to outsourcing at each of these quantities for me. And what you'll see is as my quantity increases, the savings go down and eventually they become negative, which means that at 175,000 units of goods, it's cheaper for me to produce it in-house in my own factory rather than outsourcing it. So this gives us an idea as to where the break-even point may lie. Now you'll notice that it moves from positive savings to negative savings between this quantity here. So it has to be a number between 150 and 175 where our break-even point occurs. And in order to find that out, we can simply use a tool in Excel that is available for us called Goal Seek. And that I'm going to find under my Data tab up top here. And if I click on What If Analysis, you'll see that the option for Goal Seek comes up here. But in order for me to use Goal Seek, I need to make one quick calculation here. So what I'll do is I will add one cell here where I'm calculating the savings due to outsourcing for this particular quantity, which would be the cost to produce minus the cost to outsource. And this number is going to depend on how many units of product I end up producing. So let's say if I put 150,000 and the savings are 9,000, which is what we have in our table here as well. Now what I'm going to do is I'm going to use Goal Seek to find out the exact quantity of goods where I'm indifferent between outsourcing and producing it in-house. And to do that, I'll simply go to What If Analysis under Data and click on Goal Seek. This tiny window opens up where I'm going to set the value of B17 to 0, because that is the definition of break-even here in this case, where my savings are going to be 0. So I'm going to be indifferent between the choice of outsourcing it and producing it in-house. And the cell that I want to use as my decision variable is the quantity cell, because I'm interested in the quantity of product that makes me indifferent between the two choices. And when I press OK here, Excel automatically calculates that for me and updates that value here as 156. Our simple table that we had constructed earlier told us that the quantity has to be somewhere between 150 and 175, and Goal Seek help us identify that exact quantity as 156. So far we've learned how to use the Goal Seek option in Excel to find out the quantity of goods at which we would break even between the two options that we had. The next example that I'm going to practice with you guys here is going to be using the functions sum and sumproduct in a way that is going to be very helpful for us to do simple analysis in Excel. The example that I have is for a company called Foster Generators, and what Foster Generators wants to do is it wants to ship a certain number of product between the origin where their factories are and the destinations where their warehouses are. So they have 3 factories which are in Cleveland, Bedford, and York, and each of these factories have a capacity of 5,000, 6,000, and 2,500. On the other hand, we have 4 warehouse locations which are the destinations: Boston, Chicago, St. Louis, and Lexington. And the demand at each of these locations is 6,000, 4,000, 2,000, and 1,500. What you see in this matrix over here that I just highlighted are the shipping costs. So in order to ship 1 unit of product from Cleveland to Boston, it costs us $3. And if we're shipping 1 unit of product from York to, let's say, St. Louis, it costs us $4. So we're going to use the sum and sumproduct functions in Excel to help us run some very basic analysis here in Excel. Let's say I want to find out what my total cost is going to be if I end up shipping these many units from each of these factory sites to these warehouse sites. So basically the way I'm going to read this table is that I'm shipping 100 units of product from the factory in Bedford all the way to the warehouse in Boston, whereas I'm shipping 4,000 units of product from Bedford to Chicago. And the easiest way to find out what the total shipping cost of sending out all these shipments would be to use the sumproduct function. And in Excel, if you're not aware, we can start typing a function by starting off with an equal sign. And I'm interested in the sumproduct function, so as I type sumproduct, it's going to show up here. And the first argument for this function is the first array of values, which are these individual shipping costs I have. And the second argument is going to be the array of quantity shipped, which is given in this second matrix over here. So notice that both these arrays are the same size, and that's a requirement. In order for the formula to work correctly, the quantities that I'm using sumproduct for have to be the same size. Essentially what the formula does is it's going to multiply each of these unit costs with the respective quantities and then calculate the sum of all of those products. Hence it's called a sum product. I'm going to close this bracket over here and press enter. That very conveniently gives me the total shipping cost of shipping all of these items to these destinations at this rate. If I had to do it without the sum product formula, it would have been a lengthy formula where I'd have to multiply each shipping cost with the quantity and then add it to the shipping cost for the other route and so on. But because I have the sum product formula that I can use, I don't have to write this lengthy formula that spans across multiple cells. I can simply use the sum product function to do that for me. Similarly, if you want to find out how many units you shipped from Cleveland, you can use the sum function, and for that I just need to sum it across all the warehouses, and that gives me the total number of units of product that have been shipped from Cleveland. And I can simply drag this formula down to calculate the same value for Bedford and York. This also works across columns. So if I want to find out the total number of product shipped to Boston, I can simply calculate the sum from B17 to B19, press enter, and that gives me 6,000. And I can drag this across to get the same value for each of these warehouses. So total units shipped to each of these warehouses is given in this row, and total units shipped from each factory is given in this column here. In this next example over here, I'm on the sheet called Gambrel, and here we're going to use the functions COUNTIF and IF in Excel, and you'll see how I've applied them in the case of this example, and that'll teach us how to use those functions in scenarios where we need to do such analysis. Let's come to this example, this practice example that we're going to be covering in order to learn the COUNTIF and IF functions. So we have the example of a company called Gambrel Manufacturing, and they produce these 4 types of product. These are technical products, and their component IDs are given in this row over here. So the first product is called 570, the second is 578, 741, 755. It's not uncommon for companies to give these component IDs to their products so that it's easier to keep track of. These numbers here, just remember that they're sort of like a name for the product and not numbers representing dollar values or anything. It's just the ID of the product. On the other hand, what I have listed here are the parameters for my model. The first row number 4 that we're going to discuss, is the inventory of goods that I have on hand. So currently at the warehouse we have 5 units of product 570, 30 units of product 578, 70 of product 741, and 17 units of product 755. Now we are going to be, every time our stock gets lower than 100, we order up. So if I have 120 units of product in hand, I would not be ordering any more product. But currently, because I have 5, I need to order so that my stock reaches up to the safety stock point, which is different for each of these products. So my order up to point is different for each of these products that I'm producing here. And the cost to order per unit is given in this row 6 over here. So each time I place an order for an item, I incur a fixed cost, but that fixed cost is per order, not per unit. So if I end up ordering 100 units of product in one single order, I'm only going to pay 120 once. I don't have to pay it for all the 100 units over and over again because they all come under the same order. And similarly, like all normal businesses, there's always a volume discount. So if your order size is 50 units or more, then you end up getting a 10% discount. So the final price that it costs you to order that item would be 90% of that price instead of 100%. So let's try to find out how many units do we need to place for today's order so that our safety stock is up to this mark. And to do that, I'm going to first calculate the amount of each of these products that I need to put an order for. Because my order up point for the first product is 100, but I only have 5 in stock, the difference is what I'm going to order. And the same goes for all the other 3 products. Because I already have 70 units of product 741 in stock, I'm not going to place an order for that today. I know how much I'm going to order of each of these products. I need to calculate what the cost is going to be of ordering these many units of each of these products. Now, if I didn't have a volume discount, the simple formula would have been to multiply this quantity with the cost per unit. In this case, it would have come down to $427.5 for this particular part of the order. Now, obviously, because I have a volume discount, and if my volume is above 50 units, I get a 10% discount for ordering a larger sum of units. So in that case, I want Excel to automatically know whether it needs to apply the volume discount or not. And to do that, we're going to be using the if function. The way the if function works is Excel is going to check if the order quantity is above this minimum discount size or not. If it is above this discount size, it applies the discount. Otherwise, it doesn't apply the discount. So let's see how we can use the if function to do that for us. The first part would be to write the if function. If this order quantity is greater than 50, then I want Excel to apply this 90% to 450. So basically reduce my cost. Otherwise, I added a comma for the last argument. I want Excel to use the same cost that is given to me, 450, without any discounts. Okay. So what this does now is this is going to help you decide whether it's going to apply the discount or not. We still have to multiply that with the order quantity, which is 25. So I'm going to close the functions bracket and multiply it with the order quantity and press enter. So now you see, because our order size was above 50, it's 95, which is above 50. So we got a discount, and previously our cost was coming up to $427, but because of the 10% discount, our cost has been reduced. Now, we need the same formula to be applied to these three cells as well. And here again, I'm going to take advantage of the constant cell references. Because I know that this discount is going to remain the same across the different products, so I'm going to put absolute references in front of B11. So I'm going to put dollar signs in front of B11 and press enter here. And now once I drag this across, Excel is automatically going to update the formulas for me. Oops, I'm sorry, I forgot to add the absolute cell reference for this minimum order quantity, which is in cell B10. So I'm just going to add that. Remember that the Excel shortcut for that was F4, and press enter and then drag it across again. Okay, now this formula is correct. It's going to check if this order quantity is above the minimum or not. Because it's not above the minimum, it's using the original cost of $12.50 to place our order, and that's how the cost of goods has been calculated, and so on. Next, we're going to learn how to use the COUNTIF function. We've learned how to use the if function so far. We need to understand how to use the COUNTIF function. So in this case, let's say if I want to find out how many of these products am I placing an order for today, and that would be, it's for this simple example, but just by looking at it I can tell that I'm ordering, out of these 4 products, I'm ordering for 3 of these, because for product number 741 the order quantity is 0. But in case if this row was really long and you wanted to find out immediately how many of those products you placed an order for, the COUNTIF function is going to be really handy. So I'm going to select the COUNTIF. The first argument is the range of values over which I want Excel to check if it's greater than 0 or not. Now make sure that you put this criteria, this test, under quotation marks, because that's how Excel's syntax works. If you put it without the quotation marks, it's going to give you an error. And it automatically gave us how many of these products we placed an order for today. So similarly, let's practice again with our sum function. The total fixed cost. Let's move on to our last example for this video, where we're going to learn how to use the Vlookup function. So the Vlookup function is an extremely useful function if you have really large Excel sheets with tons of values in them and you're looking for one particular value and its corresponding values. So in this example, let's see, what I have here is Granite Insurance's bonus awards scheme. So the bonus bands for awarding bonus points for target sales is given here. The lower limit is given in column A, the upper limit is given in column B, and in column C are listed the bonus points you get for being within this limit. So if you are within 11% to 50%, let's say 26%, then you get 10 bonus points. However, if you are, let's say, at 63%, then you come on within this range, you get 15 bonus points. So if you want to quickly find out what each of these salesmen get in terms of bonus points, if their target sales are these percentages, then we can simply use the Vlookup function to do that for us. We're going to start typing the function, and Excel automatically recognizes Vlookup. The first argument in the Vlookup function is the cell that you're trying to look up. In this case, we are trying to look up the values which are given in cells B15 and B29. So for each person, we want to look up their target sales percentage and then how many bonus points they get based on those target sales percentages. So that target sales percentage is given in cell B15. So I want Excel to look up B15, the value in B15. In this table here, I have to highlight the whole table because I don't know where the value can be within this table, and Excel is going to do that work for me. So I highlight the whole table. And the third argument is the output, what I want Excel to give me as the output of this function. Since I'm interested in the bonus points that this salesman gets, I'm technically interested in the third column of my table. I can simply count 1, 2, and 3. And that's what I need to put here, the column number for Excel to give me the output from. And I close the bracket and press enter, and Excel automatically locates that this 83% falls within this range here. So this salesman, Barth, should get 25 bonus points. We can copy this formula down for all the other salesmen as well. But before doing that, we need to put the absolute cell references using the dollar signs. And in this case, the dollar signs would go only on cell A6 and C11 because this table remains constant throughout our example. The only thing that changes is the salesperson's target sales, and the column index is obviously already hard-coded, so it doesn't have a reference. And I press enter. Now I can copy this formula down to get the bonus points for each of these salespersons respectively.